Hi guys, I hope you can hear me. Thank you for joining on time. In the meantime, as we buy time to get to quorum, you can let me know in the chat where you're joining me from and what you're expecting from the session. Otherwise, thank you for tuning in. For those just tuning in, thank you for joining. If you can hear me, just let me know on the chat where you're joining me from and what you expect from the session. Glad to see familiar names. Can see Senyonga, can see Hillary, can see Erastus. Please say hi. Say hi on the chat. Let me know your expectations. Let me know where you're tuning in from. We will start in a few. I'm not sure if you all can hear me. Just give me a thumbs up if you can hear me. Can't see anyone speaking on the chat. All right, then engage me. Senyonga is tuning in from Kampala. Thank you for tuning in, Senyonga. The rest, where are you tuning from? What are you expecting from the session? Hi, Matilda. Hi, Stanu, KK, Erastus, Monubi, Mark M. Let me know you can hear me on the chat. What are you expecting in today's session as I share my screen? Thank you, Hilary. Joining from Nairobi. Monubi is joining from Kisii Uni, hoping to learn something cool today. Thank you for tuning in. We have Gerald from Meru, hoping to learn about deploying applications. Stano from Nairobi, hopefully it will be an educative session. I have Josh from Nairobi, Kilonzo from Nairobi. I have Mark from Nairobi as well, more learning on DevOps. Yeah, I'm hoping you will get exactly that. So I want us to do something engaging before we go into the serious stuff. Our topic for the day is build, ship, and deploy a DevOps hands-on guide to Dockerizing apps. This session is organized by Zindua School. If you're coming across Zindua School for the very first time, we are a coding school located here in Nairobi. We're going to talk more about that in a few, but for a start, allow me to engage you in a fun game. If you're not familiar with DevOps, don't worry. It's a very simple game. Yeah. So you can go to Wayground. I hope you can see my screen. Just give me a thumbs up if you can, if it's visible. You should be able to see a screen with Wayground. All right. Cool. I'm pasting the link on chat. Thank you, Edwin. Edwin is joining from Nairobi, hoping to learn how real systems are deployed. We have Matilda from Nairobi. Thank you for tuning in. Now, I want us to all take part in this game. We are 22 of us. So click on that link. The join code, I'm also gonna paste it there. I want to see you join so that I can start off the game. Malcolm from Kanairo, thank you for joining. We are playing a game. I'll paste the link again. Make sure you join. Waiting for you to join. I want to see at least 10 people. Not limited to 10, but I want at least 10 people to join. Click on that link and join. I'll paste the link again for people just joining right now. It's a very simple game. Si ngumu, so usiogope. Don't be scared. I hope we all understand Swahili because I'm code switching. Okay, we have 7 people. Three more. It's a very simple game. Yeah. Okay, two more to go. All right, let's go. So I'll be looking to see who will be on our leaderboard today. So yeah, I can see you all are getting it right. I told you si kitu ngumu. Alma, thank you for tuning in. We are currently playing a game. Share the link in the chat if you'd want to join before we are done. Uh, you have 2 minutes left. Let's keep attempting. You have Gerald leading on the leaderboard. Let's see whether he'll maintain the spot till the end, followed by Stano. On number 3, we have KK. I don't know who that is. Okay, let's keep attempting. Second, a minute to go. A minute to go. Gerald Bado, I'm a leaderboard. No, he stands unbeaten. Let's see whether he'll maintain, and he is done. Right. KK following closely, followed by Stano. 1 minute. 1 minute. 1 minute. I close it at exactly 16 so that we can start. For those who are just tuning in, we are winding up with an icebreaker and then begin. But you can let me know where you're tuning in from and what you expect from today's session on the chat. Okay, for those still attempting, can wind up. Few seconds left. All right. So we have a tie with 3 people. I'll just end the game. We have 3 people, but based on time, Gerald takes the win, followed by KK, followed by Stano. Congratulations, guys, and thank you for engaging on the game. All right, so I'll close that section and we will go right into the agenda of the day. Yeah, for those coming across Zindua for the very first time, Zindua is a coding school. We are located in Lavington. We offer a variety of courses, but our main programs are software engineering and data science. We have a variety of specialization courses as well. I won't mention all of them, but the specific specialization course that inspired this webinar is our DevOps specialization course. So before I hand it over to our speakers for the day, I will just brush up very quickly on what it's all about. And then I will put the link to the specific specialization course. And then if you have any questions in regards to it, you can just put it on the chat, even as the speakers continue with the topic for the day. So our DevOps specialization program is a 12-week program that is specifically for developers um, into cloud automation. If you're looking to build, deploy, and manage backbone of modern software, then this specific program is for you. Um, it is specifically crafted for those looking to automate complex workflows, master cloud infrastructure, and achieve professional Azure certification at the end. Um, I believe for developers on here, this is not new to you. You're going to learn. Can see someone has texted. I hope you can still see my screen. What about data engineering? Yes, we also offer data engineering as one of our specialization course. I will continue. So what you're going to learn is Linux and Bash fundamentals. I won't explain into depth of that. You're going to learn about building automation and CI/CD. You're going to learn about containerization and orchestration. You're going to learn about cloud infrastructure and security. You're going to learn about Azure certification and capstone at the very end. I'm sure our speakers of the day are going to go in depth into this. So I won't go in depth about it. How the structure of the program looks like: you have online resources, learner management system. We have a new LMS which is going to give you curated program experience, and then our our learning approach is based on project-based learning to make it practical. And then we have the personalized support by our technical mentors, and our curriculum is advanced and anchored on certification exams by Amazon Web Services and Microsoft Azure, as well as AI integration. I will not go into the pricing, I'll just share the link, and then afterwards, I'm going to talk about it in depth. So on call, we have two people. We have Ezekiel Kibiego, who's one of our software technical mentors at Zindua. And then we also have Joseph Kalume, who is one of the mentors who will be taking us through this specific specialization. He is a DevOps engineer at KCB. So without further much ado, I will just invite Ezekiel, and then he will hand it over to Joseph. And then I will paste the link to the specialization if you need more info about it on the chat. Ezekiel, if you can hear me. What's the cost of the program? Okay, as he comes on, our programs are based on flexible payments. So you choose the payment that works for you, and then you work it out. So the first payment option is the one-time upfront payment, where you confirm enrollment by paying the 5K deposit and then the one-time fee of 60,000, making it a total of 65,000. This is the cheapest option if you're paying it upfront. We have two installments as well. 5K deposit is a constant, and then 31,500 monthly installments for the 2 months, making a total of 68,000. And then there's the flexible payment called Lipa Mdogo Mdogo, constant of the 5,000 to confirm enrollment, and then 13,500 monthly for 5 months. Available through credit vetting by Chapter Global. For this, because it takes longer period, of course, you'll have to go through vetting. For our alumni who've been part of our programs before, that is our core programs, either our software engineering core program, there's a 15K discount on the total cost. So that's an added advantage for you if you are a recurring student. That's our pricing for the person who was asking on the chat. So without further ado, Ezekiel, if you can hear me, allow me to hand it over to you. If you have any more questions, Feel free to put them on chat. I will paste the link to the program on the chat as we move on.
Okay, thank you, Grace. And because of time, we've got like 22 minutes gone already, so we can just go ahead and start pretty much immediately. As you've heard, I'm Ezekiel. Nothing much to say at this point. We can go ahead and invite Kalume to grace the day. Kalume, you can just take it up.
Ezekiel. So, good evening, everyone. As it has been introduced earlier, my name is Joseph Kalume, DevOps engineer at KCB, and software developer by profession. So, on today's session, as it has been said, it's about build, shape, and deploy. But first things first, we'll have to understand what is DevOps first for the new joiners, for the ones that we were together on the last sessions. Maybe it's just a reminder. It's not bad. Then after that we'll also try to understand the Docker, because what we are doing focusing today is building and shipping and deploying, but with Docker. So I'll share my screen as I explain some concepts. So just a minute as I share the screen. So is my screen visible? Is it okay? So thank you.
Yes, it is.
Yes.
Thank you. Thank you. So yeah, this is our first slide that we'll be looking at. Uh, but first, DevOps. DevOps is not a new term to majority of us. It came somewhere maybe in the years of 2005 is where the DevOps started to come into this world. And what aspired DevOps to come is how the previous guys or the previous application were managed. It was hectic because the teams were much siloed. We have the development team, we have the operations team, we have the QS team, and also we have different teams sitting on different desks doing different things. But the main goal, all of them, is to deliver softwares. So it brought a lot of bottlenecks. One of the bottlenecks was delivering software that were not production ready. And if we say production ready, is that a software is delivered, but there's no vigorous testing that has been done, and also maybe configurations that are being shipped to the production guy are not the ones that should be taken to production. Another thing is the time it takes for the production team to get the application ready, because the application will first the team will sit, will plan, then it takes to code, the coders will do the code, then after the code, then another team will do the testing. Of the testing, then it is thrown over the wall to the production guys. So the production guys are getting a software that they don't understand it. That's when the DevOps come. So DevOps come, what it came to do is it came to remove the silos. So all these teams are now are able to work together and to produce a software. So if it's security, security is embedded as this software development starts. If it's QA, QA is able to write the test cases as the developer is writing the code. Previously, it was the developer to write the code, give the QA, QA now start write the test cases, then do the test. And the quality of the software that was being generated was not as per the standard. But as the world evolved, when the DevOps came, then an era of AI came. So era of AI also came to revolutionize how DevOps works, because we use that DevOps is about automation, the day-to-day tasks. If it's maybe you want to be updating your infrastructure. You just write scripts. If it's an Ansible playbook, you write Ansible playbook. You update your servers. If you want to provision infrastructure, if it's servers, if it's database, then you just write a Terraform files. You provision your infrastructure. If it's software delivery, then you just go and do your GitHub actions. You deliver your software. But now we have AI. So AI what came to do is that on advantage of DevOps, it's not like the talks are there and I'm not able to comment maybe that AI is here to replace developers, to replace DevOps, to replace who and who, but as people say, those who are using AI correctly will not be replaced. AI will replace those who are not engaging it, who don't know to use it. So it came with two careers, if I can say it. There's AI ops and we have ML ops. So ML ops is how we ship our models to the production. So we take our models from the development team, we train the model, then after training them, then we take to production. Then the AI ops now is first scenario of AI ops which we can use is it able to tell our application will fail in production? Maybe we are running a Docker container, and this Docker container maybe it start giving anomalies. The logs that are being generated are not normal. So the AI ops is able to, if there's an agent there running, it's able to detect the anomaly. Then when it detects, then it able to give us an alert. Or if it's something that can be sorted, then the agent can proceed and solve the issue. So that's how DevOps is evolving nowadays. So that's all about DevOps. So DevOps is a culture. It's not a kind of role of someone to do. Yeah, we have this one who will be enforcing, who will be maintaining the standards, who will be defining, but it's also a culture. Everyone should be working with DevOps in the back of their mind. Like if I'm building a software, I should understand this software be delivered through a pipeline. I'll not be going to type the commands on my machine, then I ship the container to the final destination. But it will go through a pipeline. So what the pipeline does, the pipeline expect me to provide A, B, C, D, so that the pipeline can do what it's supposed to do, so that I can get a software. So that's what I can say about DevOps. Uh, so on our split session, it's about the build, ship, and deploy. I'll handle the first bit of build. What are we building? We're in a software business, like we're doing software. So what we're building is software. So the developer write the code, and after writing the code, then this code should be taken to the next stage. Is it development stage? Is it a pre-prod stage? Is the production stage? So how do we take it there? Then we need to understand how we'll get our artifact to that end. And our artifact does not exist in isolation. There's so much dependencies that depend on this. There's so much configuration that should be done so that our software can perform the same way it was performing on my local machine. Then once it's get there, then when I ship it, then I should be able to ship with all these other related artifacts together. Once it ends there, then we need to make it run on that environment and be usable to the users or our target audience. So that's why we have our first thing we say, why Docker in DevOps. Docker came to resolve the issue of it works on my machine. Previously, and I remember it's something that I experienced uh, during my college days. You are writing a project, it works fine. Maybe because one reason or the other, give maybe a machine brings an issue, then you ship the code to someone else's machine. Then once it gets there, the code is not working. Then I say it's on your machine, only to realize that you don't have some server on that end. So on your side, you had some server, you had export the port if it was port 3306 maybe. But on the other side, the guy doesn't have server, doesn't have some server, or doesn't have Apache. You need Apache on your service to run. So those are the issues that Docker came to resolve. So what it does is that it takes all these it all takes all these dependencies together. It's embedded on your artifact and it ships. So once you get it to any other machine, provided it has the platform for Docker, then we expect your software to run comfortably. So one thing the Docker solves is that it's consistency. So what we have on our machine is the same thing that will take it to the next stage. Then it's portable, it's lightweight compared to the VM environment, because before containers were working on VM virtualizations. So you have the host OS, then you virtualize the environment. So you have maybe another 3, 4 machines on top of your machine. So it was kind of heavy. So the benefits on DevOps is that we have the fastest ACD and we're able to deal with the microservices because we have a functionality, we're able to deliver it. It does not depend on another service to run, because if you can do a front end and a back end separately, then it's good because it not allows all of them to exist in the same code base. And also for the bit of collaboration between the devs and the ops guys, because since we are building it, we are making sure that all the dependencies we need it has, so that the moment we ship it to the ops guys, what they need to do is just to follow the script, to follow the script that they need to follow, the deployment notes, and start the application without any hurdles. So Docker architecture. Docker is not, we've said Docker once or twice. So it has two components, which is the Docker client and the Docker engine. So the Docker client is what you are interact with. You say Docker images, you see the images, you say Docker PS, you see the containers that are running. Maybe you say Docker PS minus A, you say see both the running containers and the stopped containers and all that. Then we have the Docker engine, which is the demo, which is running on the background. So this listen to the APIs, the command that you give, then it handles what you want to do. If it's about tagging an image, if it's about building an image, if it's about communicating with another Docker instance, in a case where there's a Docker swarm, you have a class of Docker instances that are running, you want to manage your images. So this is the pictorial view of the Docker architecture. We have the client or the API. Then you send the API, go to the host. Then the host performs all the operation. If you need to go to the registry to pull an image, to push an image, if it's just building, then it's build. You get your image. So today's session is a hands-on session. So I'll share with you the repository so that we can do together uh, on what we'll be doing today. So I expect everyone to participate fully on this session today. Have you received the link? Yes?
Have you shared a link on the chat? Oh, yeah,
Yeah, I've
yeah.
shared the link on the chat.
Okay, yeah, yeah.
So yeah, so that's the link on the chat. So is my screen visible?
Yes, yes.
I'm sharing VS Code. So yeah, this is our application. So application is kind of, it's an Python application where you are connecting with the model. So our API, it when we send a request to the when we send a request, then the request is taken to the model, then the model assess our request, then it gives us a response. If a response is negative, it's positive. If it's neutral, so any statement. So first we'll check the structure of our application. So application, it has, this is the application file, then you have a Docker compose, we'll see it later. Then you have a Docker file, also see it later. Then you have this file. This file, it will take us through on how, on the processes to do or the steps to take so that we can make our application run. It's a README file. And it's a good practice writing README, because for someone who will be going through your application or your infrastructure file, can understand what you are doing, with comments also on your code. Then you have the requirements file. Yeah. Then we have this file, which is a workflow for the CI, GitHub Actions. So this is the automation. We'll check it on the tail end of the session also. So our session today, on my end, I will be using a more lightweight containerization platform, which is called Podman. I hope it's something that you've heard before. Podman and Docker almost the same because they do the same thing. The difference is that Podman is more lightweight compared to Docker, because Docker runs with the daemon, which is not heavy on the Podman. So I'll be doing Podman, but from your end, you'll be using, if you have Docker, it's okay. If you don't have Docker, then you can install Docker. Maybe anyone who need to assistance on setting up Docker, or everyone is okay. If it's in on Windows, just go to Google. You get the APK for Docker. If it's on Ubuntu or any Linux distribution, I think if you type Docker help or Docker, you get the various commands that you can run. Docker sudo Docker install and all. Then you can proceed to install the application. So yeah, let's follow our README file. So this is our README file. So first step, we are running our application locally. So the first step is where the developer is developing the application. So developing application, you write code, you have to do various
Kalumi,
steps. Yes,
there's a quick question here. Are the
yes,
Docker commands similar to Podman? If you can respond to that quickly.
yeah. Just replace the Docker with Podman.
Okay.
Yeah. If you can see my screen, Podman, then so if you can see those commands, these are the same command that we have on Docker. We have build, Docker build, and Podman build the same. Podman compose and Docker compose. Then we have the remove, this for containers, this remove images to run the container, Docker pull to pull from registry, push to the registry. And we have this for tagging images. So in the similar commands. Are we okay, Ezekiel, there? And the rest of the team?
I
Thumbs up?
guess so. You can continue. Good. Yeah, yeah, yeah.
It's okay, thank you. So first, so the developer is writing the code on his local machine, on her local machine. So he'll need to compile the code, test the code with various tests that he has, so that he can ascertain that my application is okay. Now I can proceed to give it to the next guy so that they can do their tests and finally be deployed for the users. So first, you need to see if you have Python on your machine. So we are deactivating our virtual environment for Python. So we'll do it from the start. So first, we'll set up the environment, the virtual environment for Python. After you set up the environment, then you need to activate the environment, which will run this command for Windows, the first command, and for Linux and macOS, you'll use the second command. So in our case, we'll go with the first command. So now we are on the virtual environment of Python. So now here we're going to install all our components and dependencies that are required to run our application. So first, we're going to install the requirements, what is then on our requirements file, and say enter. So this may take some time, maybe on our case, maybe it's for the first time. So once that is okay now, we can run our application comfortably. Now let's wait for application to start. This may take some time because you need to load the models, and the models are beta because it has some component. So the application now it has started. It has started on port 500. So you can see here, this is what we were expecting, running on port, which is this one here. Now you can have this curl if it's running on your terminal. Maybe if you want to test it on Postman, sorry, then you can have this. So if you have Postman, so let's send this curl on our chat and see the response. The text that is in it is an ordinary day. So let's open another terminal here. So here So our application is exposed on port 500 as we had seen, and the endpoint that we are looking is analyze. So the statement is for postman. So if you say I'm sick, then it should give you a response. So the sentiment is negative because you're sick and it has been rated this way. So maybe say I'm happy and see the statement, the rating, then the statement is positive. So at that juncture, then you are confident that my application is doing what is needed maybe. Now, once you are there, you can proceed with the application to give it to the next guy. So on that instance now is where you're coming, the Docker comes in, where you need to containerize the application, ready to ship it to the next people to test it and to deploy it and test it. So let's go back to our VS Code. So now after that, now we proceed to Dockerize the application. So on Dockerizing application, here we'll go through our Docker file, how our Docker file is structured. We need to optimize our Docker files. So we open our Docker file and see how our Docker file is. So our Docker file is kind of separated into two parts. We have the first part here, and we have the second part here. So we are doing this. These are multi-stage Docker file where we have the part to package application. Then after packaging application, we are only copying only the artifact that we need from that application. We don't copy everything. This helps us to have smaller images, which is fast to build and also to ship, because tell me you are pulling an image which is maybe 3 GB compared to an image which is 10 GB. It's not the same. And also starting, maybe on starting that image also it requires more resources because the image is kind of big. So this is our Docker file. So we'll come back to our terminal to run the commands to build this image. So back to our README file. So this is the command that we run. Our command is podman build -t, podman build -t, sentiment API latest. So if we go through this command, the T is you're trying to tag the image, and the sentiment is the name of the image. Then you have the tag which is latest. Tagging images with the latest tag is it's not encouraged. And the reason it's not encouraged is because once you tag the image latest, then you push a new tag with the same latest tag. That means you're going to override what is there. When this image is deployed, then maybe it has some issues. You'll not be able to roll back because the previous image, you don't have the previous image because you overwrite it. But if you did say this image is v1, or say, yeah, let's say v1, then that means the next release you can say it's v1.1. when you deploy this v1.1 and it fails for one reason or the other, you are able to roll back. You have a backup plan where you roll back to v1.0 so that the users can continue to use the application with what it is there as you come back and fix the issue that you've experienced. So when you are tagging images, try to tag with definitive tags rather than letters, because if you be saying letters, then you'll lose track on last image what was fixed about, on this image what was fixed about. And if you can see on the versions, one we have the major version, we have the minor version, then you have a fix that where you have see you can see 1.1.0. So that means we have the major version, the first one, the second is the minor version, then you have a fix. So we'll Podman build that image depending on the Docker file that is there. So this might take some time because of the models. And if you can see our Docker file here, maybe I have forgotten to take you through. We are trying to get this, we are trying to cache these models on our image. When we cache that, that means it will take less time to start this image. If we need to get the models remotely when our image now starts, that means first the first request will take time. Then also the image will also take time to start. So that's why our image will take time. But the other images here for the same. So when we do Podman images, yeah, they are. So you can see this is a P1, this is the latest, then this is a Python image. These are those, and our focus is these two images here. So you can see all of these images are of the same application, but they have different, like what I was saying. So in case I deploy V1, if in case I have V1 running, then I push latest, then I deploy latest, then latest fails to run. Then I'm able to revert back to V1 and the process move smoothly. So what you saw, we can come here and run these images. So now our README file. So you say V1. Then because 500 is already exposed with that application, we can say this is 501. So we have, sorry, it's Podman on my case. So you have Podman run, then -d, that means application run on the background, -p, that's the port, then we have the name of the container, then we have the image that will be running this container. So we can say, see, there's already a container with the same name. So maybe we can rename this with v1 container and run. So here our container has started. So you can see the progress of our container. Podman log. So we're trying to See the logs as the container is starting. When as F, that means we'll remain seeing the logs in real time. But before there, sorry, podman PS. Yeah. Then do the podman logs. And the container ID. Yeah, you can see our container has started. Our container has started. So the same way, but our container started with, so since our container started, now we can go and test this container. And we expect the same outcome as we did previously. You can see here's the request. I have fired a request and here it has come. So the request is 200. In case I send a request that is empty, you can see this is request which was empty and it has given us a bad request. So if you're doing the same, you see if you send us positive statement, it will give you a positive response. Rating with this rating, you give a statement with maybe a sad word, it give you tell you it's a negative sentiment. So after we are satisfied here now, we can say we are now able to ship our application to the ops guys now. They can deploy this application and maintain it. And on the other end, they're not required to install, because if you are keen on this part here, on this tab, we had to virtualize our environment. We have to virtualize the environment. We have to install the requirements from the requirement.txt. But here, we just need to run the container. We just put my run, and everything else has been coupled in that artifact. So it will not depend on the machine. Once the machine has Docker or it has a containerized environment, then the rest has been taken care of. So the cries of it works on my machine now, it has been eliminated. Are we together there? Thumbs up if you're okay. Oh, it's okay, it's okay. If you are still installing the dependency may take some time because of the nature of the application. You see, we are trying to communicate with the model, and you can see a model that have been trained with data, they're kind of big, so they will take some time, but yeah, it'll be there. But that's what we expect at the end of the day. So now we need to ship this container. So how do we ship now? That's where we come to push our image. So you put my login or Docker login on your machine. Then you push. Once you push, then you expect it to see on the other end. So there's a container that I pushed. Let's see if we can have it here. So we have Docker Hub. So there are so many registry. We have ECR, we have ECR for AWS, we have ECR for Azure, we have the Quay registry. So we log into this registry. So once you podman push or docker push, then you expect your so here's the image with the tag being latest. So yeah, here's the image with the tag being latest. So if you can pull this, I push with sha instead of the name, but it is the same. So if you pull this, then that means you can have the same image that I have on my end. So that's how we ship. So after we push it here, then the other guy on the other side, their role is just to pull this image to follow the deployment that we have given, that you should need to Docker run will expose these ports, run on the background mode, then check on the logs, send this type of request, then should be okay. Are we okay there? Yes? If you're okay, before we proceed. So that's good, that's good. So now we are moving to the part of we've shipped, but now we've shipped with uh, podman push or docker push from your local machine. Now we need to deploy it. So where do we deploy it? So there's another question, which is more dependent on your environment. Where are you running your applications? Are you running your application is where it will determine how you will ship your images or you ship your code. The screen visible? Yeah, here we are. So how do we ship? There are so many ways to ship this or to deploy this, sorry. But on the era of DevOps, we are using CI/CD pipelines to do. So CI, continuous integration, and CD, continuous delivery and continuous deployment. So CI, continuous integration, is where every push or every commit, we're able to build this commit, we're able to test it commit, and ascertain that it's working fine. So on the continuous delivery, we're able to we have the artifacts that are ready to run on production. So CI/CD, we test regularly, we commit regularly, we test regularly. That means we are able to produce as many features as possible within shortest period of time. So we have this YAML file. We'll go through it, and also we'll talk about the AI a bit on DevOps as whole or on the IT sector. So if you can see, this is the name of our run. So the first bit is on branches. So the pipeline will run if we have a pull request on the master branch. So we are pushing on develop. After develop, then we match the code to master branch via pull request, which will go through approval. So once the pull request has been approved and it has been completed, then a pipeline will run. So what does a pipeline do? So these are the steps that will go to go check out the code, then it will set up the environment for Docker. Then after setting the environment for Docker, then we'll do a Docker login. So Docker login, you can see we have secrets. This is falls under DevSecOps. How do we handle our secrets? Sorry. How do we handle our secrets? Our secrets should be handled with so much care, because once they're exposed, that means we are exposed as individual or as organization or as the tool. So in GitHub, we have environments, variables, we have secrets where we can store these our secrets. So our pipeline go and check the secrets, pull, use it at that time, and once it's done, then the runner is destroyed. So after that, then the step that we've done, we'll go, we'll do a Docker build and a Docker, we'll do a Docker build and a Docker tag. So this is the building process and tagging. So you can see it's user Docker build push action. So once we are done with this, now we can deploy it to the server. So in this case, maybe we are running an EC2 instance, then that's where we run our application. So first thing, we expect that on that EC2 instance, we expect the Docker to be running or a containerization platform to run, either Docker or Podman or any other one. So what we'll do, our script will do, or our pipeline do is that it'll go and log into that server. So you'll provide a host, which is the IP, the user, and also the SSH key to log into the server. Once it has logged into the server, then we have this image. So the first step is to pull the image. Once the image is pulled, then it will stop a container with the same name. After stopping the container, then remove the container. As we did, because there was a container that was it has stopped, but it has not been removed, so you cannot run a container with the same name. You need to stop that container first, then remove the container. After that, now we can run our application. So the application should run. It should start. It should not restart unless it has stopped. Then it runs on the background. The port exposed is the port 500. Then the name of the container, this one. Then the image tag. Once done, then we expect to see this this statement. On that repository I've shared, I think you can see that there is a button for runs. So under runs, there's a run that it ran yesterday, is the one that published the tag to the register that we've seen. So that's the whole process to build your application, to package it, ship the application, and deploy it. So now inside we deploy to server. Maybe you are deploying your application maybe to a Kubernetes environment, because Kubernetes is a platform, one of the platform that is able to manage the containers. If you have one container, two containers, it's easy to manage. But if you have a couple of containers, scaling, descaling, playing with the traffic during the peak hours and low traffic hours, container is able to Kubernetes is able to manage those containers effectively. So as we started, we've said about AI ops and ML ops, but also AI. There's AI called cloud code, as you've seen on the all over the internet. It's an AI that's able to write code, that's able to debug code, that's able to fix issues. So if this AI is capable of doing this, why you with a know-how or who understand these things, why don't you use it on your advantage? Why should you spend a whole day maybe trying to optimize a Docker file that maybe once you give it to AI, it can optimize it, but you will trust it, but you have to verify it also, because maybe sometimes it will give you images, maybe the images they have a vulnerability. So you see the image that has been given, is it safe? You'll go through the Docker file, but it fastens the process. Maybe you want to write a pipeline like this. It may take you some time, because if you are starting this, you are not able to memorize these commands. Maybe with time, because something will be doing on a day-to-day basis, you'll be able to know after checkout, then I should set up Docker. After Docker, then I need to log into Docker Hub and build and push the image. So AI is able to help you in doing these tasks. But AI will not able to help you to do if you don't know what need to be done, because else something else that if you don't know how to run an application, even if you give an AI an application or a command that I want this application, it gives application. If you're able to look on the code and ascertain that this is what I want, this is what I should get. So on that is where Zindua now comes in. So what Zindua comes in to do is now to take you through that journey, to help you understand, to teach you how to write the code, if it's DevOps, how DevOps is, how should you perform your tasks, and give you a certificate once you're done. So all these, we've gone through a single application, we've gone through the process very fast, but once you're in that course, then you have a whole 12-week course where we'll take you through these things, we'll teach you. And also another thing about it is that you'll be belong to a community where able to learn, able to connect, and it's good for your growth. So on that juncture, maybe I give it to Ezekiel if there's no question on my end. Ezekiel can take it from there and guide us further. So thank you.
Okay. I'm not seeing any extra question here, but guys, you can drop them, and if you want to speak, you can just let me know. You can raise up your hand if you want to comment or ask a question verbally. You can be able to go ahead in the next 5 minutes. Then, if there's no questions, then we can be able to call it a day. You can invite Grace to finish it up. Yes, there's a question. Can also Nginx be deployed? Kalume?
Maybe the question is kind of be deployed as in, because it's very, like it's not specific.
Okay. If it's not specific, Edwin, can you unmute and try to rephrase your question in a better way? Edwin?
I can see someone has said, can you run an application with the Nginx? So yeah, Nginx can run as container, as a containerized. I've seen Nginx running as containerized. So you can also run it, but containerizing an Nginx is not a good idea. It's not a good idea, but you can run an application that will be utilizing Nginx. But containerizing an Nginx, because Nginx should be a kind of stateful, not stateless as the other application. Yeah, there's images with the Nginx. There's images with the Nginx. If you go to Docker Hub and find those images, that are there.
Kalume, there are further questions on the chat. I don't know whether you can be able to see them.
You can host React Next apps on Nginx. Are you using Nginx because Nginx, there's time that is used as a load balancer, as a web server. So maybe you want to use Nginx to achieve what? But yeah, but also it should be very specific on what we want from Nginx, because Nginx it runs a uh, couple of rows on what you need to do.
I'm just saying,
Someone is speaking.
I don't know if I'm audible. Am I audible?
Yeah.
Yes, I'm saying that I think I just needed to correct you on the part of Nginx. Nginx can be used to host apps, and it can host usually the front end frameworks after they have built their artifacts. So you can go ahead and push the folder there, the static assets,
Yeah.
so that you can serve them. And also you can use it as a load balancer, as you have said.
Okay, thank you. So next, any security concern when using Docker images or containers? Security concern first, uh, the user that is running on the Docker. When running Docker containers, avoid running as root users, because someone, when get access to the container, can use that root user to escalate privileges and do damages. So avoid running containers with root users. And also the containers should not be having vulnerabilities. That's why you need to be remediating your containers regularly. If you are building images, the base images should use base images that are very secure, because those vulnerabilities that comes with those Docker base images can be exploited by hackers maybe, and can do a damage on your side. Being DevOps engineer, are you supposed to know the various backend framework languages being Dockerized? Yeah, that's why we're saying DevOps engineer should have an understanding of software development, should understand couple of languages, not entirely like proficiency in it, but can she go through a process of building a application, containerizing it, deploying, testing it, and all that. So should have a know-how on how various languages work. Because let's say it's a Python and you don't know how to package a Python application, then how will you automate that process? Because you should be able to understand it manually before you automate the process. You can't automate what you don't understand. Is it that okay? So next, so Kubernetes is used to it's a orchestration platform. So you have so many containers, you give them to Kubernetes, or you have containers, give them to Kubernetes, then Kubernetes is able to manage you for that. So what Kubernetes manage to is first the network. So maybe you have two applications within the Kubernetes, the two applications can communicate within that platform. But from my side, the best part of it is managing the containers. Maybe you're running maybe it's an e-commerce platform. Then there's an is it called Black Friday? So during Black Friday, the requests are so many. People maybe they're buying tickets, maybe people maybe they're buying items, then the requests are so many. So if your application is running on Kubernetes, you're able to scale these containers automatically. So there's something called HPA, which is horizontal pod autoscaler. So what does that? Once the resources for a certain pod has been exhausted, it's able to give you the same instance of an application to for your request to be served to. So once the window uh, for the huge traffic is over, then these containers are able to be terminated and just maintain the minimum number of containers that you've set. So maybe you say the minimum container should be 5, the maximum should be 20. So during the peak hours, the containers will be spin to 20, but during the normal hours, then the containers be running 5. So this thing on your own, maybe on local host, not local, but on a Dockerized environment without Kubernetes, then maybe you will be receiving complaints that the traffic is heavy and the application has crashed. Then that means you need to repair these containers or give more containers. Once the traffic is over, then go and terminate these containers manually. But on Kubernetes, it's able to manage these containers. So Kubernetes is a containerization platform where the containers are being managed. So you have containers, give to Kubernetes, don't you'll not be bothered about the containers anymore. Once you give them the enough resources to run, then the rest the Kubernetes will take care of it. Orchestration, it manages the containers. Load balancing, then let's say you have various containers. So load balancing, if you have in case you're using the ingress first, the ingress on Kubernetes, that means it's able to distribute this load fairly to all the containers in the backend. So maybe it's an application, there's a front end, then there's a backend. So on the backend, maybe you have 3 containers running. So once your traffic goes through the ingress, then from the ingress, then these containers will be will be served. Also, so that's where load balancing, because load balancing is an instance where you have more than one instance of the application, and then those instances are getting traffic depending on the rule that you set. Maybe your rule is go for it's an IP based, or it's a list with the list connection, or it's a round robin. So that's way. So orchestration is manages the container. Load balancing is the distribution of the traffic that is coming in. So I think I have answered the question for demonstrating the Kubernetes, how it works. Stano, by answering the question for, yeah. Are you okay? If you're still here, thank you. So Ezekiel, back to you.
I guess that's it. I don't know whether Grace is here to finish it up, if she has additional information to share.
Okay, if we have no further questions, I have pasted the link again to the program on the chat. I'm also going to share a post webinar email with all relevant links that you may need in accordance to our specialization program. We have an intake coming in on the March 2nd. I'm also going to share more details on that on the chat. For those who are on email, sorry, for those who are asking about the community links, I shared as the session continued, but be sure to get all the links after the session. Stano is saying, are there rewards for the top 3 in the quiz we had earlier? For now, not really, but but if you sign up for the March 2nd DevOps specialization, naweza nitafuta. I can get much for you. That's okay, Stano. I think I didn't take a screenshot. Let me take a screenshot on that quiz. All right. Anyone with a question before we call it a night? I think we are way past our schedule. Okay, it seems there is no more questions. That's it for today. Thank you for tuning in. Thank you, Joseph and Ezekiel, for taking us through the session. Thank you, everyone, for tuning in. Looking forward to have you join our DevOps incoming program. That's it from us tonight. Have a lovely evening.